In this question, we have a magnetic field of 6.5 Gauss in a chamber, and in this chamber we are incidenting one electron perpendicularly to this magnetic field with this given speed. Now we have to explain why the path of the electron is circular, and we also have to determine the radius of the circular path. So first we'll write the given quantities. This is the magnetic field inside the chamber, and this is the speed with which the electron enters in the chamber. And we know that here the magnetic field and velocity of the electron is perpendicular to each other. So we can say that the angle between them is 90 degree. So if I draw the figure for this, then it will be, suppose if the magnetic field is like this, going inside the plane of the page. Then we will have our electron which will be traveling in this direction perpendicularly. And you know, when the electron enters perpendicularly in a uniform magnetic field, then magnetic force Q into V cross B will be acting on the electron, and it will be deflecting continuously the electron from its path, and because of that the path of the electron becomes circular. Okay, so we can say that the magnetic force acts as a centripetal force. So we can equate it and write it in this way. This is the centripetal force, mv square divided by r, and this is the magnetic force which acts on the electron when it enters in the uniform magnetic field. This can be simplified in this way: qvb sine 90. 90 is the angle between velocity of the electron and the magnetic field. You can see here electron is moving like this way in the plane of the page, and the magnetic field is moving inside the plane of the page. So angle between them is 90 degree, and sine 90 is equals to 1. Now we need to calculate radius of this circular path. So we will be making r subject of this equation. So this r goes on this side, and this qvb sine theta will come in denominator. So you will get this kind of equation. This v will get cancelled. This m is actually mass of electron, so which is given in the question. They may give or they may not give, so you have to remember this value, mass of electron. After substituting all these values, you will get radius of the circular path. And then they have also asked you that why the path of electron is circular. So the reason is, whenever the electron is entered perpendicularly into the uniform magnetic field, then magnetic force, this much magnetic force acts on the electron, and this force will deflect the electron continuously from its path, and so this force acts as a centripetal force. So it will force the electron to move in a circular path which is perpendicular to the magnetic field. In next question 4.12, they are telling you that obtain the frequency of revolution of the electron in the circular orbit. And you have to consider all the values from example 4.11. So this example. In the same example, here you have to obtain the frequency of this revolution. So this we have studied in topic 4.3, motion in a magnetic field. So the formula for frequency is this, and how we'll obtain this formula. See, we know the concept over here that whenever a charged particle is entered perpendicularly in a uniform magnetic field, then magnetic force will be acting as centripetal force. So I will be using the same formula to obtain the formula for frequency. So you can write here mv square by r is equals to qvb sine theta, but theta is 90 and sine 90 is equals to 1. So I'm not writing it over here. Now you can see here 1v will get cancelled. Now we also know that v is equals to r omega. This you have studied in 11th standard. So you can write here m, instead of v we will be writing r omega divided by r is equals to qb. Now you can say, see, this r gets cancelled. But omega is equals to 2 pi f. This also you have studied in 11th standard. So you can write here m into 2 pi f. F is the frequency. Now make f subject of equation. So f is equals to qb divided by 2 pi m. So this was your required equation. So it's not necessary to write this in exam. You can directly use this equation for frequency. And now all the values are given in the question. Q is our charged particle, which is electron in this case. So value of Q is 1.6 into 10 raised to minus 19. Value of magnetic field is given. And this will be mass of electron. So after substituting all the values, you will obtain frequency as 18.18 into 10 raised to 6 Hertz. This can be written as 18 megahertz. Now they are asking you that does the answer, means does the frequency depend on speed of the electron? Our answer will be no. Frequency is independent of velocity. Simply you can observe this formula. See, in this formula, velocity is not there. So you can say that frequency does not depend on velocity. But then they have also asked you to explain that why frequency does not depend on velocity. So you can say that, see, if velocity increases, then what happens? Then radius of the circular path also increases. How? See, you can understand this from one example. जैसे छोटे बच्चे खेलते हैं, पत्थर को एक स्ट्रिंग से बांधते हैं and then they just revolve it. तो जब आप उसे गोल घुमाओगे, if the radius is small, right, then the speed of the stone also will be very small. But suppose आप चाहते हो कि उसको आप जल्दी जल्दी घुमाओ, तो आपको रेडियस भी बड़ा करना पड़ेगा. मतलब जैसे आप स्पीड इंक्रीज करोगे, तो आप जो पत्थर को घुमा रहे हो, जिसको आपने रस्सी से बांधा है, जब आप स्पीड इंक्रीज करोगे, रेडियस आपको इंक्रीज करना पड़ेगा. छोटे रेडियस पे आप बहुत ज्यादा स्पीड से उसे नहीं घुमा पाओगे. सो यू कैन से दैट वेलोसिटी इंक्रीजेस, देन रेडियस has to be increased. Means these two are proportional to each other. You can see that from this equation. ये equation कहाँ से आता है? From the very same equation. If I make V subject of equation, then I'm going to obtain this equation. And from here I can say V and R are directly proportional to each other. Now our question was whether the frequency depends on velocity or not. So see, frequency is equals to 1 upon periodic time. But what is periodic time? I can obtain the formula for this from the formula of speed. So speed is equals to, I can say, distance covered divided by time taken. But here distance covered will be 2 pi r as the path is circular. So from here t is equals to 2 pi r divided by v. But as we have seen here that if radius increases, then velocity also increases. These two are proportional to each other. So if these two increases simultaneously, I can say that this quantity remains constant, means t remains constant. If t remains constant, then frequency also remains constant. So you can say that frequency depends on periodic time and t remains constant on increasing or decreasing velocity. Therefore, frequency is independent of velocity as periodic time does not depend on velocity. So frequency also does not depend on velocity.